So here we'll be looking at implicit differentiation. And for implicit differentiation, y is implicitly a function of x. To be honest, it can be any variable, but usually we use y. So y is implicitly a function y of x. The easiest way to show implicit differentiation is through an example. So let's do an example. Let's say we have x squared plus y squared equal to 9. And we want to find if my pen cooperates, we want to find dy dx. Okay, let's differentiate. If we differentiate x squared, we're going to get 2x. If we differentiate y squared, we're going to have plus 2y. But because y is implicitly a function of x, we have to account by the chain rule. So times dy dx is equal to 0. Now we just need to solve for dy dx. So dy dx is equal to minus 2x over 2y, which is equal to minus x over y. Let's do a slightly easier example, slightly harder example, where we have e to the xy is equal to e to the 4x minus e to the 5y. And we want to find, again, dy dx. Okay, so let's differentiate. On the left-hand side, we're going to have e to the xy multiplied by the derivative of xy, where y is implicitly a function of x. So we're going to have y plus x times dy dx using the product rule. This will be equal to e to the 4x times the derivative of 4x, which is 4, minus e to the 5y times the derivative of 5y, where y is implicitly a function of x, so that would be 5 dy dx. Now let's just multiply out to make our lives easier. So we're going to have y e to the xy plus x e to the xy dy dx is equal to e to the 4x times 4 minus 5 dy dx e to the 5y. Now let's collect all our like terms of dy dx. So on the left-hand side, we'll have dy dx, and then x e to the xy plus, because the 5 dy dx e to the 5y comes to the left-hand side, plus 5e to the y. And then on the right-hand side, we're going to have 4e to the 4x minus y e to the xy. Now dividing out, our final answer is going to be dy dx is equal to 4e to the 4x minus y e to the xy over x e to the xy plus 5y e to the 5y. And that is our final answer using implicit differentiation.